Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 8.3.1. We're going to start with our M&Ms, which covers angles. And so everything we need to know about how to classify angles will get you down here. But the angle itself is two rays. And those two rays have a starting point, or I guess the book sometimes calls them endpoint. If the race ended here, it wouldn't go on forever in the other direction, is what I'm saying. So we're going to call them starting points, but still, either way, it's the vertex of the angle, has two rays coming out of it. And so this is what we're measuring on the inside. And we use a protractor to measure the number of degrees in a angle like this. This one looks like it's close to 45 degrees, but we would need the protractor to know for sure. And then you've got the classifications for angles. So you got your acute angle, which is less than 90 degrees. So this is an example of an acute angle. You've got your right angle, which measures 90 degrees. Everything is being compared to this. If the distance between here is smaller, because it shrinks because this guy leans in, then it's going to be an acute triangle. If it widens, it's going to become an obtuse angle. And then the last kind of an angle, which is kind of important for what we're going to be doing in 8th grade math and in high school, is the straight angle, which technically is just a straight line. And this vertex here really is just one of the infinite number of points on that line. This measures 180 degrees. So 4 different basic kinds of angles. So estimate the measure of each angle below. So if I'm going to estimate this, first, let's think about this for a second. Let me take a circle, create that circle, and let me create these little lineys here. So is that about the center point right there? Yeah, that's about the center point, and this would be about the center point there. So if we put all of those, so let's make sure that's right there in the middle. That's pretty good. Okay, so I'm going to group all them together, and so that would be like a 90-degree angle, right? So here, 90 degrees, 45 would be right around here, so I thought it was a little bit less than 45 degrees, so I call it a 40-degree angle. Now, if we want to know for absolutely certain what that is, then go ahead and pull up the protractor and set the origin on the vertex. Does that look like it's 40? Actually, it looks like it's maybe more like 38 or 39, but still. It's a general idea. We're just estimating somewhere around 40 degrees. Let me do this. No, I didn't want to do that. I wanted to do, what does that appear to be? 142, 140. So I guess it would be a 37-degree angle going in the other direction. Okay. Here, this is a little bit more than 90 degrees. So how much more? I called it 100. That's pretty close. This guy right here, let's actually rotate this around a little bit so that they see, yes, it's definitely a right angle because they put a box in there, so you don't even have to estimate that. Anytime you see that box in there, that tells you it's going to be a 90-degree angle. And then this last one, let's find the vertex there. And so does that look like, that kind of looks similar to that one, to be honest with you. But it seems like it's a little bit smaller, so I said 35, but I'm kind of curious what this one is. Let me get you out of there. I don't need you anymore. Boom. Let's bring down the protractor. Let's set the origin up right here. Let's rotate it. Get that on 0. And this is pretty much the same as the last one, right? It is about 37. So these two angles here are pretty much the same angle. Just this one has the vertex down here. This one has the vertex on the side. All right, a little bit of review here. Write an equation that represents the diagram. So this line, Cecil's tightrope, is 2x's plus 10. That has to be the same length as 24. So if we take away the 10, and this becomes 14. So 2x's are now equal to 14, and that's what we would be doing here if we had removed balanced sets. 2x's are equal to 14, which means each one of those has to be equal to 7. 7 plus 7 plus 10 is 24. Yep, that's the same length, so we know we've got that correct. Here you've got a couple of angles that are complementary. So the total is 90 degrees, but 55 plus this one gives you that 90. So if we subtract 55 from the 90, you get 35. So this must be a 35-degree angle. So we're using algebra even when we're solving problems involving geometry and angle measures. Okay. Oh, goodness. I'm going to pause it here. I got to go plug in my machine. I'll be right back. Alrighty, so it's probably a good idea for you to just pause. Well, I guess you don't need to pause. Work out a couple of these problems. In fact, I'm going to work out 4 problems, and I'm going to do one of each. So a division problem, like this one. Instead of doing 9/15 divided by 4/3, if we change that to 9/15 times the reciprocal, now we can go ahead and multiply straight across and get us 27/60. Or we could have done some cross-canceling. The 3 and the 15 share a factor of 3 together. That becomes 1. This becomes 5. So that's going to be the same as 9/20. So we would declare that as our answer. When we're adding fractions together, we need to make sure we have common denominators, both adding and subtracting fractions. So I'm going to change this guy so it has a denominator of 20. I like the 19/20. That's fine. Or technically negative 19/20, but I need to change that by multiplying both the top and the bottom times, not times 5, times 4, isn't it? So this is going to be 16/20, 16/20. And now when you add them together, you keep your denominator, you do a subtraction here because you're adding a positive to a negative. So whenever you've got opposite signs, you're going to subtract and keep the sign of the bigger number. 19 is bigger than 16, so it's going to be -3/20. Let's do a multiplication. Actually, let's do this one. It's a subtraction problem, but technically it's not a subtraction problem because if we do KFC, that's going to become add the opposite, so it becomes -3/4 plus 11/16. But guess what? It's going to become a subtraction problem again because you're adding a positive to a negative. So I'm going to rewrite this by multiplying it times 4/4 times -12/16 plus +11/16 gives you -1/16 because you're going to do a subtraction and keep the sign of the bigger number just like we did here. -1/16 is the answer. And then the last problem we'll work through is this one where you got some repeated multiplication happening there. So if I started off with 2/9 times 14/15 times -9/10, I know my answer is going to be a negative because I've got positive times a positive times a negative. You got an odd number of negatives, means it's going to revert to a negative in the end. In the numerator, I could multiply straight across if I wanted to, but that's going to make for a huge fraction that I have to simplify. So I'm going to turn this into prime factors. 2 times 7 is 14. And I'm just going to write this as 3 times 3, not -3 times 3, because I already know my answer is going to be negative. So I don't really have to worry about the sign anymore. And in the denominator, 9 is 3 times 3. 15 is 3 times 5. And 10 is 2 times 5. So now where are the common factors? The 2 cancels out with the 2. You got 2 3s on the top with 2 3s on the bottom. And there's a 2 and a 7 on the top. There is a 3 and a 5 and a 5 on the bottom. We have nothing more to simplify. So we're going to end up with a 14 on the top, and 25 times 3 is 75. So that ends up being our final answer. All right. So if you needed me to work out these 4, I'd be happy to do that. Just let me know. Oh, goodness. Box plot information. Is this the last problem, or is there another one after? Oh, we got a couple more. All right, we should do this. I'll just run through it quickly. All right, so it says Ms. Carpenter asked each of her students to record how much time it takes for them to get from school to home this afternoon. The next day, students came back with this data. So this is the raw data. It is not put in order, okay? So we need to put it into order so that we can find the median and the quartiles and the minimum and the maximum. So this is the order rearranged in order. Now, the most important thing to do here is count your numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in my ordered pair, or ordered data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh no, what is going on here? What is all of this? Hold on, I need to look this over. This is driving me nuts. Okay, I just miscounted. There's 20 here and there's 20 there. So I've got all the numbers accounted for. So we need to find the median. And so the median is going to be the halfway point. So half of 20 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then from the other direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know what I'm doing with those lines there. This is really confusing me. At any rate, our median is going to be the halfway point or the average of those two numbers. So that's 19.5. Then we take the median of the lower half of the data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's these two numbers. The halfway point of those two numbers. You know what? I don't know what's going on here. This is driving me crazy. I'll come back to you. Hold on. All right, I got it all cleaned up. Looks a little bit neater here. All right, so once again, your median is the number in the middle. And in this case, you got two numbers in the middle. So you got to find the average of those two numbers. So you add them together. 17 and 22 make 39, and 39 divided by 2 is equal to 19.5. So your median is going to be 19.5. All the numbers less than the median are a part of the lower half of the data. And so you find the two numbers in the middle there because you got 10 numbers there, right? So you're going to find halfway point between those two. So you add them together. 17 divided by 2 is 8.5. So that's going to be your first quartile. Your upper quartile is the median of the upper half. So these 10 numbers, take the two numbers in the middle, and you get 42 plus 43 is 85, and 85 divided by 2 is 42.5. Your minimum is easy to find. It's the lowest number. Your maximum is the highest number. Okay. Then it says, and we're going to get to the box plot in a second, but then it says you want a combination histogram and box plot, and we want the width to be 10. Okay. So in order for that to happen, we need to find, all right, so all the numbers between oh, maybe that's what this was. Let me go ahead and get rid of these guys now. I bet I was doing a combination for the box plot or for the histogram. So I'm going to now highlight everything. So everything in the first 10 would be those guys right there. Then between 10 and 20 would be there. And then between 20 and 30 would be those. And then between 30 and, oh, there's only that one, right? And then between 40 and 50 would be all of those. All of those, there we go. And then the ones in the 50s. So it looks like we got 1, 2, 3, 4, 5, 6 students recorded times to get home between 0 and 10 minutes. Technically, the 10-minute person would go in here, but there isn't a 10-minute person, so you got a total of 6 of them. Here you got a total of 4, you got a total of 2, total of 1, total of 5, and a total of 2. So when we put this into a histogram, here we had 6 people who took between 0 and 9 minutes to get home. Here we've got 4 people who took between 10 and 19 minutes. Here we've got 2 people. Here we've got 1 person. Here we've got 5 people, and here we have 2 people. So since the histogram references a number line that's counting by tens, essentially, in the x-axis, in the horizontal axis, we can use that number line for a box plot as well. So 3 would be right around here. That's this point right there. The 8.5 would be somewhere around here. That's this section right there. The median would be right around there. So there's our median, 19.5. 42.5 is halfway between 40 and 45, so it's going to be right there. And then your maximum 55 is right here. So we can create our box plot above the histogram, and we can get a little bit more information, right? Here we see the spread of the data. We see where the median is. Here I can't tell where the median is, right? So the box plot helps me in this situation. Here I know where the minimum is. Here I have no idea what the minimum is. It could be 0, 1. It could be any of those numbers in there. So by having a combination box plot and histogram, not only do you get to find the 25% intervals of the quartiles, the median and the minimum and maximum, but you also get to see how many students fit into each category, into each interval with the histogram. So both of them put together give you just a little bit more information to draw conclusions. Now, it did ask us for one other thing. It says find the mean, and I'm not going to do that, but this is the mean, 25.35. When you add up all those numbers and then divide by 20, you will get this as your answer, okay? It says, how could you better describe, consider the situation, make a conjecture as to why this data has a shape with 2 peaks. Does it have 2 peaks? I guess it does. So you got 1 peak here and 1 peak there. I guess you've got a couple of situations there, right? A lot of the students probably live very, very close to the school, and so it only takes them a few minutes to get home. Quite a number of students here live maybe out in the country. Maybe there is a subdivision outside of the town, and it takes a little while to get there, right? Between 40 and 50 minutes to get there. And so those students come to the school as well. And so these people are the ones having to travel a great distance to get to the school, while these people live right in the neighborhood of the school. All right, Kirk's parents are really enjoying their portable music players and have downloaded many more albums. Maud now has 225 albums, 135 of which are heavy metal. And in case you need a little inspiration as to which heavy metal albums maybe you should go listen to, I highly recommend Judas Priest's Screaming for Vengeance. Megadeth's Rust in Peace. Guns N' Roses' Appetite for Destruction is one of the greatest albums of all time, as is Metallica's Master of Puppets. And I'm partial to Kiss Destroyer because I used to jam to Detroit Rock City when I was your age. So yeah, those are some good albums. Claude now has 450 albums, 270 of which are heavy metal. Which of Kirk's grandparents has the higher probability of listening to heavy metal music? So if we take each one of those and we convert them into their percents, you'll see that both of them are the same percent. They both just happen to have 60% of the music in their iPods or whatever music player they're listening to, or listening with. Both of them have 60%. So there you go. Rock on, Kirk's grandparents. All right, and then the last problem. Josue called his father to say that he was almost home. He had traveled 61.5 miles, which was 3/4 of the way home. Write and solve an equation to calculate the total distance he will travel to get home. All right, so that's 3/4 of the total is equal to 61.5. So if we want to solve this problem, we can just multiply each side times 4/3. And these are going to cancel each other out. And 61.5 times 4, what is that? No, I don't want that. Stop it. No, don't open. 61.5 times 4 is 246 divided by 3. And so let's go ahead and take that and divide it by 3, and you get 82 for your answer. So it must be 82 miles to get home. Now, using a diagram like this, you could figure it out, where if he's 3/4 of the way home, that means that each one of these fourths, you got 3 of them, right? Take 61.5 and divide it by 3, you get 20.5. And so now multiply that times 4, and you get 82 for your answer. What's another way that we could say that? You got 61.5 over the total. Instead of saying 3/4 of the way home, you could have said 75% of the way home and said 75 over 100, but then we could also just write 75% as 3/4. So why not just leave this like that instead of having it be 75 over 100, right? They're equivalent to each other, and we have learned that we can simplify them. So if we cross multiply, we get 246 is equal to 4 times x, which is pretty much, no, 3 times x. 3 times x, that's a 3 up there. Change that. And then when we divide both sides by 3, we're going to be right here. And you're going to get your answer of 82. So a few different ways to solve proportional type situations. All right, so we are done with today. Thank you for having patience with the box plot problem. I just had to remember what my thought process was, but we got it all figured out. All right, long session. Sorry about that too. Let's move on to the next activity. Take care. Bye.
Hey, feeling